Let's start with the basics. How to create a for loop and how does it actually work. To create a for loop, we have to use the for keyword. Right after the for keyword, we need to specify how many times we want this loop to re-execute its code. As you already know, this is the key thing about the for loop. It executes or iterates a specified number of times. First, we need to create our iterating variable, our iterator. This variable is usually denoted only by a single character. The most commonly used one is the I character, short for indexer or index, so I. You can use any other character or even a word to describe your iterator, as we will see shortly. It depends on exactly what you are doing, since sometimes it can make your code more readable. Some other commonly used characters for iterators are J, K, N, M. Now, let's say that we want this loop to execute 5 times, and for each execution we simply want to output the value of the indexer itself. The indexer is actually a vector, so we are creating a vector specifically for our for loop. Since we want to execute the loop 5 times, we need to create a vector from 1 to 5. So let's manually create it. So 1, 2, 3, 4, 5, just like that. And inside our for loop, we simply want to print the value of I, the current value of I. And to end our loop, we need to use the end keyword, just like with an if statement. If we run it, we will simply get each of the values of our indexer in our command window on a new line. Like this, there we have it. I is 1, 2, 3, 4, and 5. Now, it's important to note here that the amount of times the loop is going to execute is actually dependent on the number of items in the vector of the iterator. It's not dependent on the actual values, but on the number of items. We can just as easily change these to 10, 20, 30, 40, and 50 and run it again, and you will still get only 5 iterations, the values that we just created. We're not going to get 50 iterations, we're still getting 5 iterations because we have only 5 values. If we try to perform the same task without a loop, first we need to create it. So I1, let's call it I1, equals to 10, 10, 20, 30, 40, 50, and then we want to print each of these values on a new line. We have to say I1 of 1, I1 of 2, I1 of 3, I1 of 4, I1 of 5. We're addressing each of the values individually, and this is exactly what the for loop does in this case. As you can see, we're taking the indexes, it's taking the indexes as the number of iterations and printing the actual values. As you can see, the difference here is that here we did it in just 3 lines of code, and here we needed a lot more. And if we want to extend these numbers, if we want to have 100,000 numbers here, well, we're still able to do it with just 3 lines of code with the loop, but we can do it manually. Now, instead of writing manually the values like this, we can simply use the vector generation techniques that we know. So we can simply say if we want the loop to execute 10 times, we can do it from 1 to 10 like this, and if we run it, we get the values from 1 to 10. Like I said, we can make it, the important thing is the amount of values and not the values themselves. We can make it from 1 to 100 with a 10 increment, and we will still get only 10 values. Actually, this should be from 0. There it is, and we still get 10 iterations, or actually 11 iterations. And once you know this, well, you can generate a loop that will execute any number of times that you want. Now, let's generate a vector from 1 to 20, a new vector, so v1 from 1 to 20, and let's say that we want to add +1 to each of the numbers in the vector. Now, for I equals to I, and here we can use length of v1, so length of v1. So this loop will now execute as long as we have values in the v1 vector. If we change our v1 vector, the loop will change along with that vector. They are tied together now. And this is good because if you change something in your code up here, you don't have to go back and change the loop as well. So we are going to address each of the values of the vector. Now I will take the values from 1, the length of the vector is 20. So we are going to get indexes. I will take the values from 1 to 20. So here we will say v1 of 1, v1 of 2, v1 of 3, v1 of 4, v1 of 20. And we want to add 1 to each of these values, plus 1. And let's run it. And we get the vector itself, and each of its values have 1 added to them. Now, on every iteration of the for loop, the whole vector was actually outputted on our command window, and we can actually closely see exactly what it is doing. It's modifying the elements of the vector one by one. Now, in the beginning, we start with a vector from 1 to 20. On the first iteration of the loop, this is the result from our first iteration of the loop. As you can see, the first element is no longer a 1, it's now 2. On the second iteration of the loop, the second number became 3, then the third number became 4, then the fourth number became 5, and so on until it's iterated through the whole vector through all of the values of that vector. And now this loop, if we suppress the output and simply print the result of our vector at the end, this loop, since we used the length of our vector, will work for the vector regardless of its length. So we can even create a vector from 1 to 1000 with a step of 100 like this, and it's still going to work because this will take the length of v1, the length is 10. So this, the I will always be from 1 to 10, from 1 to 10, like that. The iterator will always be from 1 to 10, and these are the indexes of that vector. These indexes allow us to address each of the elements of that vector individually. Now let's say that we want to run the loop only on the first half of our vector. Well, we will simply divide the length by 2, so just like that. And if we run it, you can see that now only our first 5 values got 1 added to them. The rest don't have any modifications on them. This is because now our I is from 1 to 5, and only the first 5 elements of the vector were addressed. And yes, you can do the exact same operation in just one line of code by using your advanced knowledge of vectors. So if we create a v2 from 1 to 20, and we say v2 from 1 to the length of v2 divided by 2 equals to v2 of the same thing, length of v2 divided by 2 plus 1. Yes, you can do this, but the question remains, should you do it? Because what is more readable? Is this more readable or is this more readable? This actually will run faster, this operation will execute faster than this, but sometimes it's just better to go for the more readable code than to save a couple of seconds of execution time. So always keep this in mind when you are coding readability. Go for readability. Now, this is why MATLAB is a high-level functional language. It has many built-in functions that make your life easier, and it doesn't force you to write your code from scratch all the time. The difference between the two approaches here is that the for loop has a body, and here you can do additional things along with that vector, additional things. You can add as much code as you want there, and you can do this with this one-line expression. What if you want to multiply your vector by another vector? Not element by element, but if you want to generate several new variations of your same vector, something like this. So let's say that we want to generate a version of that vector multiplied by 2 and then by 3. So multipliers equal to 2, 3, 4, 5. Let's add a couple of them. So 2, 3, 4, and 5. We can do what we can do here is, let's get rid of this. We can say, instead of addressing each individual elements from the vector, we can say v1 times multipliers of I, and I is no longer going to be from 1 to the length of v1, it's going to be to the length of multipliers, since the variable here now is the multipliers. This will now take the whole vector multiplied by the first element from multipliers print the output, then take the second multiplier. Let's run it, simply run it. There we have it. Let's make this to 500. Let's run it, and there we have it. As you can see, we have the same vector v1 multiplied by a different multiplier. This you can't do with element by element operations.